And while there are a very large number of mutations, we've said, every time a genetic sequence is copied, there can be mistakes in that copy. And whilst complex cells, as yours and mine, have mechanisms to correct those, simple viruses don't have such complex mechanisms to correct them. And therefore, the rate of mutation of viruses, which are present in millions of people around the world, we know currently there have been 29 million people around the world who have been test-proven cases. But if you look at the fact that in the United Kingdom, we're saying around 350 people have been test-proven. But if you look at the wider apps based on self-reporting of symptoms, the estimates are probably that around 3 million people within the UK have had that virus. So millions and millions of people have the virus. Each person that has the virus replicates millions and millions of times. So there's many opportunities for mistakes to be made in the replication of the single-stranded RNA, which makes up the coronavirus sequence. And probably 10 or 12,000 slight variations, but they're very minor variations. One that's particularly gained prominence is this D614G mutation. It's a single point mutation, and people have been interested in it because it is within the spike protein of the coronavirus, and we know the spike protein is the way in which the virus latches onto this angiotensin converting, this ACE2 receptor on the surface of the lung epithelium. That's the way it's internalized. But actually, that mutation has become so prevalent around the world that actually scientists kind of consider that mutation actually really just to be the virus. That is what the pandemic is. And if anything, that's made the virus slightly more infective. It's one of the more infective strains. That's probably why it's so much more prevalent than other mutations that have been found.